All right. Good afternoon, everyone. Appreciate your time today. My name's Daniel Bounds. I'm from AMD. I have about 8 years of CloudFest experience, so it's great to be here as always. At AMD, we love CloudFest. It's been a journey for me in the last 3 years as we thought about how we bring this new product to market, this EPYC product to market. We started with nothing more than a meeting space, and it has really turned into a complete movement for us. We started with 2017 introducing in private and in NDA with a lot of you that were here, and started to build the momentum and the excitement around AMD EPYC. And then mid-2017 was the first time that we launched EPYC fully into the market. So for those of you who have been fully versed, or many of you who have deployed at this point, I wanted to take just a minute and give you an idea of where we've been before I tell you where we're going with EPYC. So they say get your audience's attention, so hopefully that was dramatic enough for you. What it really boils down to is EPYC is an amazing product, and for us, we considered a kind of a once-in-a-lifetime opportunity to work on something that is so compelling and so valuable to the customers. At the core of it is a design theory and focus on the modern data center. What do we need? Well, we see more often than not, core density is a critical success factor, but it has to be balanced. So memory bandwidth and leadership I/O are also critical components to creating the microprocessor of the modern data center. And then as a lot of us have experienced, especially over the last year, in 2018 in particular, advanced security features are absolutely critical. And when we take a look at what this means compared to the alternative, what you have typically bought over the last 5 years without an AMD alternative, the difference couldn't be more significant. So we look at core scaling. EPYC outperforms significantly. We look at I/O and memory channels, a third more memory channel, or a third more memory bandwidth that you can get with AMD EPYC. And that's something that was really, really critical as we looked at the microarchitecture and thought about how do we balance all of this amazing compute capability in the context of a server system. I'll talk a little bit more about security in a second, but not just root of trust, but being able to extend that to encrypt memory that otherwise would be in the clear and vulnerable with the precious data of your customers. And then the other thing that we did in this context was we introduced what we called the no compromise one socket server. And that was something that, in my experience, 20 plus years in the industry, this is the first time that we were able to give our customers, to give you, and to enable you to solve your customers' problems with a full and robust one socket solution without compromise. So I'll talk a little bit about the impact of that as well. And then consistent feature sets is something that I want you to remember, because it's incredibly important as you're architecting different type of servers to meet different type of workloads. You need the flexibility to scale up and down with core count and performance, but you don't have to sacrifice memory bandwidth and I/O. And that was one of the key points that we had as we designed this. I talked a little bit about security. For us, security is job one. We needed to create a more secure microprocessor. In the age of spoiler and meltdown and foreshadow, there are architectural differences that set AMD apart, that make it immune to most of what you've seen over the course of 2018. And we by no means as an industry are done with these type of vulnerabilities. What we have to do is have a laser-like focus on how do we prevent, how do we harden, and more importantly, how do we invest in the future of security technologies? And so everything that you see on this slide is a nod towards how we can go and create a better, more secure platform that you can then extend to your customers and share with them the capabilities that their data is trusted. Secure memory encryption and secure encrypted virtualization are at the core of what EPYC does from a security perspective, either encrypting physical memory. We know from studies that close to 43% of all of the vulnerabilities, all of the breaches that occur, actually occur from the inside out. You've got a bad actor on the inside. The ability to prevent scraping and other vulnerabilities with secure memory encryption is absolutely critical, and to do it without materially impacting performance is a radical innovation in this area. But the more interesting piece to this from a cloud and hosting perspective is the security capabilities that we provide in virtualized environments. So the ability to isolate and encrypt a particular virtual machine, tie it to a unique key, and that unique key then can be given to your tenant or can be managed in a different fashion, but it keeps your data secure regardless of if you're in a virtual environment in Site A, Site B. It provides that level of continuity of security. So what does all of this mean? So what it really means is EPYC has been architected from the ground up for the modern data center, and the modern data center is in many ways a cloud and hosted data center. So whether you're selling IaaS or PaaS, whether you're selling a social platform, whatever it is, EPYC, because of its core scaling, because of its bandwidth, its memory bandwidth, is truly a game changer from an economics perspective. With enterprise IT, one of the things that we've seen that has proven to be a dramatic impact to a lot of especially on-premise clouds and data centers has been this idea of being able to do everything with a one-socket server. You no longer need to design to the confines of a second socket because you get all of the features and all of the benefits, and in most cases, all of the performance with a single socket EPYC. And then for high-performance computing, it's also an amazing product because you have the memory bandwidth, the memory scaling, and the I/O attach. 128 lanes of direct attach, full bandwidth I/O that can support a range of configurations with accelerators really amps up the capabilities, especially in the age of MI and AI. And I only talk about the two on the right-hand side of the slide because that's where your customers are coming from, and you need to be reassured that the applications, the ISV community have embraced EPYC as we have rolled this out over the course of 2018. And in point of fact, the momentum that we have had from a cloud provider perspective in 2018 has been excellent. From Microsoft Azure, AWS, Hetzner has been a great partner with us, most recently Mylock and others. These are examples of platforms that have adopted EPYC and figured out ways to create instances that really matter to their customers. A great example is, with Azure, you can get an HPC-tuned cloud instance that performs amazing on some of the most critical codes, computational fluid dynamics, wharf codes, things that you typically wouldn't think about putting in the cloud. It opens up possibilities for those. So we love the traction that we're starting to get there. We're excited about having the conversations with you this week to see how EPYC can be impactful in your environment. And to double click down just a little bit, there's a number of customers who've begun to publish testimonials and help us tell our story in a more meaningful way. The Pandora quote is one where when I read it first, I couldn't believe it. The high-density cores of the AMD EPYC have enabled Pandora to gain more performance and less physical space, lower operational overhead, and faster return on investment. You really can't ask for more. So it's a combination of things. It's never just one thing, but the ability to drive more density, more capability, and expand the economics of your business with AMD EPYC truly give it a leadership position in cloud and hosting. And we've also had amazing examples with folks like Packet, where because of the way that they adopted it, because of the way that they embraced the one socket, they can offer their customers the same level of performance at 50% of the cost. So it's, more and more amazing stories are starting to pop up every day as we look to 2019. The ramp looks very strong, and we're excited about the way that our customers are serving their customers with EPYC to make a better value proposition. One of the things that we get asked continually, being relatively small in the market, is what level of traction are you getting? How can I get to your products? And in the context of CloudFest here, we would love to have the conversations with you around what systems are going to make the most sense for you in your environments. For your customers, there is a movement that you can take advantage of from a public cloud perspective that I talked about just a second ago. But there's also the world of hybrid. One of the key aspects of our launch of EPYC was to ensure that every major OEM on the planet had platforms at the ready as we introduce this product and continue to ramp. From Dell, EMC, Hewlett-Packard to Supermicro and Cisco, this is not an exhaustive list, but it is a list of key platforms that are really critical as we look at building infrastructures out based on EPYC and doing it as fast and efficiently as possible. And equally important, being able to address unique vertical segments was also an element of how we rolled out EPYC and made sure that we had the right coverage. We believe that our partners have truly become EPYC in this process and stand fully behind them. So as we double click down and we think about the applicability in cloud and hosting, one of the things that we've thought about as we not only design the processor, but really have opened it up into solutioneering, so creating stacks of software that are tuned and optimized for EPYC. At a high level, there's still a set of unmet needs that we continually think about how we address. It begins with security. I was at the IDC conference, it was I think 2 weeks ago at this point, and we've always paid attention as an industry to their top 10 lists. Security has always kind of been in the top 5, but it is an unmitigated #1 concern of customers today. How do I build the right tool set? How do I create the right infrastructure to manage and mitigate security in my environment? And so a lot of those technologies that I talked to before, the secure encrypted virtualization, the secure memory encryption, play into that. The other piece that they talk about is, how do I create a better economic model? I'm competing in many cases against, these mega scale operations that gain economies of scale that I can't even dream of in a reasonable amount of time, but I aspire. And the question is, how can I change the game? How can I think about resources differently? And I'm going to get into that in just a second. And then also, in the age of big data, in the age of continuously ballooning need for more and more storage, how do I address that? How do I deploy HCI in an effective way? EPYC provides breakthrough value in all of these. From the encryption that I talked about to the fact that the system was architected to enable 2 terabytes of addressable memory in this generation per socket. So that's a 4 terabyte system. Now, no one is generally has the bankroll to configure that way. That means also that you can get to much larger memory footprints much more cost effectively and change the dynamics of those systems today. The other piece is the flexibility that you have with the I/O enables greater resource management, whether that be through higher bandwidth networking, the way that you architect your clusters, or the way that you implement acceleration in the context of your service offerings. We offer a significantly different value proposition. And then finally, the ability to create the gentleman before me was talking about a 24 NVMe drive, HCI killer box. You have to have a huge amount of I/O to go configure those with BY4 for high performance. We're really excited about the systems that partners like Supermicro are developing that take advantage of this. And when you combine that hardware with the innovations that are happening from an HCI perspective, from vSAN to SimpliVity with HPE and many others, it is a solution that this market has needed for some time. It really gets us to the point where we can change the game to a large degree. So I want to talk a little bit more about the context of what those unmet needs and what the solutions that EPYC bring to the table actually mean to data center operations. So one of the things that we looked at, and this is an example that could easily be a cloud hoster, it can also be an enterprise. Anybody who's building out an infrastructure, at some point, it changes from state-of-the-art to easy. And where that dividing line is really depends on your business model. But ultimately, we know that as you look at even N-2 platforms, and this is all based off of data that we gleaned from IDC, the administrative costs continue to go up every year. The average lifespan has moved from somewhere in the 5-year range to 7-year range. It's really radically, we're holding on to our IT longer and longer, but what we don't see are all the hidden costs that are associated with that. And one of the things that customers talk to us about is, as I'm thinking about this problem that I want to solve, this IT tax, I can go one of two directions. I can go with the other guys and I can configure a 2-socket server, and it's a great option for them. But then we ask, what could you do? How big of an impact would it be if you deployed an EPYC 1-socket server? And a lot of the questions come back around, well, I won't have the same level of performance. Well, actually you will. The vast majority, if you look at the heart of the stack and where most customers, most data centers configure their servers, you can actually take a 32 or a 24-core EPYC single-socket server, get all of that compute capability, all the performance, all of the memory addressability, but you don't have to pay for the second socket, the second CPU, the power and cooling overhead that's associated with that. So what it really means is it creates a disruption in the way that you think about total cost of ownership and managing both the CapEx as well as the OpEx. That administrative cost goes down. The hardware cost goes down. The licensing space goes down. The licensing is a critical one. So the example that I'm showing you here is based off of a calculated example with VMware licensing. So think of this as a virtual infrastructure. Our older infrastructure was 6 racks worth of fairly densely packed servers. You have the ability to solve that problem with a 2-socket, but in this case what we're showing is if you deploy a 1-socket, you can reduce your overall VMware licensing cost by 63%. It's a fairly significant. Anything that is going to be licensed on a per-socket perspective will greatly benefit from this, as well as all of the savings from a space and a power and a cooling perspective. So what this really means is that we can boil it all down by switching from a 2-socket, hard on the market, pervasive solution today to an EPYC 1-socket solution. Pound for pound, cost per year per VM can go down by as much as 45%. So a significant change in the way that we can think about not only the operational costs and the aspects that implies in our operating model, but it also means that we can think about what we can do with all that space, all that power, all that money that we spend on licensing to do more, to grow our business. So for us, this is why we built EPYC in the first place, and why we really believe it is a product that in many ways is architected for the cloud, for hosting. Whether it's the core scaling, whether it is the I/O, whether it's the memory bandwidth. I'm hitting on these really hard because I want you to take those away. There is a difference, and it's significant, especially as you think about how you can serve your customers, their applications better and more efficiently. Certainly for virtualized environments, it's a game changer. For lower total cost of ownership, to a certain extent, if you have old and aging infrastructure, it'd be crazy not to consider this or pull the trigger on updating to EPYC. And then, the reason that we're all here is because our customers need to run their businesses, they need to run their business applications, they need to run their research applications, they need to run a wide range of applications that, I'm standing here today, talking about the momentum that we've had for a reason. Customers have already embraced EPYC, and we actually look at 2019 as a fairly significant inflection point in the way that adoption is going to be driven. But we don't stop. One of the things that has been critical for us is as we get back into this market, all we ask is for the ability to compete. The opportunity to have a discussion with you, and the opportunity to show you what our solution can do for you. Part of that is also rooted on our commitment to our roadmap. Going back to those initial pictures, we came to CloudFest in 2016 with a vision and a roadmap. And that roadmap that I and the others presented in 2016 is the exact same roadmap that we have in 2019, and our commitment has never been stronger. We also have a commitment to open and industry standard ecosystems. And so one of the things that you'll see in the market today, and even more pronounced as we move forward, is this idea that we embrace the larger ecosystem, whether that be the IHV community and all of the hardware partners that form the solution that we want to bring to market, the memory partners, the accelerator partners, the fabric partners. On the ISV side, making sure that we're listening to them and making the changes that we need to embrace everything from business applications to high performance applications. And then there's this other piece which is different for us. If you think about our roadmap and you think about the public statements that we've made in the market, EPYC was a fairly significant departure from what you can get from anybody else today. It's a multi-chip module. The way that we get to the increase in memory channels is the architecture is different. You've got a multi-die approach, which we think is the wave of the future. And that continues to get better as we roll out our roadmap. And a great example of that is our next generation product. So as we think about our first generation, that's codenamed Naples, we talked about this. One of the things that we wanted to make sure that you knew was that we were absolutely on track from a technology perspective. And that last bullet on the previous slide was all about process node leadership. The ability to move from 14 nanometers to 7 nanometers was just as much about our business model and the way that we partner with the best and brightest from a fab perspective as it is the design of the chip itself. And those in combination give us the ability to truly drive this level of innovation that most of us haven't seen in this industry for quite some time. And that leads us to our next generation. Our public statements have been around delivery mid this year. What I would tell you is don't wait for that. This product is codenamed Rome. If you've read about it, our previous one was Naples. We have this thing with Italian cities, and so we like to say the road to Rome is through Naples. There's a tremendous opportunity to embrace this technology. The competitiveness of not just the product, but of the subsequent product and of the roadmap could not be stronger. We moved from 32 physical cores to 64 Zen 2 cores. Zen was the code name for our initial core. Zen 2, I know, very creative, is the code name for our second core. But we did that in a way that not only enabled us to pack twice as many cores, but we actually increased instructions per cycle at the same time. So the performance is absolutely killer. In the context of this, we made some announcements relative to this bottom footnote, or this bottom bullet here around the first to enable PCIe Gen 4. And again, doubling the bandwidth to those accelerators and to the networking devices that you have in your system. At the high end of the spectrum, this is a game changer and something that segments of the market like high performance computing and other bandwidth sensitive areas are really, really focused on and really jazzed about. But the reality is EPYC continues to get better and better. And so we're excited about not just where we're going, where we are right now. We think that from a cloud and hosting perspective, this is absolutely a killer product for you to build a better solution for your customers. So with that, I would say, we could not be more pleased to be here. We are so excited to talk to you. We have a booth out in the main demo area, or the main show floor. Come see us, get a tchotchke, see some magic. But more importantly, we've got a couple of breakouts too. We've got one on the memory encryption that I talked about this Tuesday, and then we have different rotating talks that we'll have in our booth. We really want your feedback. We really want to work with you. And so very excited. And by the way, you can get a lot of this information and more, especially customer testimonials, on amd.com/epic. So with that, that's all I have today. Thank you very much for your time. I appreciate you.